Hey, we're going to talk about the distributive property. It's the last property. Remember, I want to have you to watch these by Tuesday. It's the last property that I want to talk about. I'm going to break up the distributive property into two different videos. I'll film another one on Friday morning that'll get uploaded. The distributive property, it's a world of hurt, okay? We've got to kind of break it down, but it is extremely useful once you pick it up. So I'm going to start with this distributive property is, we all know that 3 times 2 equals, 3 times 6, I guess we can say is 18, right? And I also could write it as 3 parentheses 6. When the 3's next to the parentheses, that's the same thing as a multiplication problem, right? So now, if you remember from, second grade or whenever you started to learn multiplication, that what this is 3 sets of 6, right? And you could write it as 6 plus 6 plus 6 equals 18, correct? You guys cool with that? Great. So remember that, okay, because I'm going to come back to that. I'm going to use that as an example with the distributive property, or the distributive, but that's stuff that you've got to know. Then the other one, and we all know here, we've got going on is 3x plus 3y. They're not like terms, being that this is an x and this is a y. We can't add them together, so the sum of 3x plus 3y is 3x plus 3y. You guys cool with that? All right. So those are the 3 points that I want you to know beforehand. Now, this is when the distributive property comes in, is if I've got 3 standing next to the parentheses, you got to remember that's multiplication. And then I've got x plus y inside the parentheses. Now, with combining like terms, that x and y cannot be added together. Okay? So, if you could, one way you could look at it as this is 3 sets of x plus y, just like 3 seconds ago when I had 3 times 6, it was 3 sets of 6. So you could rewrite this as x plus y, that's one set, plus x plus y, that's a second set, plus x plus y, that's my third set. Now you get to combine like terms, where you've got x and x. So that is equal to 3x, okay? And here you've got y, y, y. That's 3y. So you put a plus sign there, you can't forget that. So 3 times x plus y in those parentheses is the same thing as x plus y plus x plus y plus x plus y, right? When I combine my like terms, I have 3 x's and I have 3 y's, right? So this is the answer to that guy up there. You guys cool with that? Great. Now, an easier way to do it, instead of setting everybody up as this bag, or this, an easier way to do it, instead of setting everybody up into this, long addition problem, is if you have 3x plus y, okay, you can just do 3 times x, which is 3x, right? And 3 times y, which is 3y. And you bring down your addition sign. So you got to remember the distributive properties when you distribute. Well, here I'm distributing that 3. I'm distributing it to both the x and the y. Where 6th graders screw the distributive property up is they do 3 times x and then don't distribute it to the y. Whatever's in the parenthesis, you've got to distribute it to all the things inside the parentheses, to the point where, I guess I should do that, we're to the point where you will see long convoluted problems like 5 parentheses, x plus y plus z, right? And now you've got to do 5 times x, which is 5x, 5 times y, which is 5y, and 5 times z, which is 5z. You guys cool with that? So again, you're distributing this 5. It's when everything gets distributed. And you're distributing that 5 out, because if you remember, you have 5 sets of x plus y plus z. So that means you've got 5 x's, 5 y's, and 5 z's. All right. Another analogy that had been told to me that I like is if you had, say, 4 parentheses x plus 5. what this is saying is, and you can think of these parentheses as like a bag, okay? And what this is saying is you have 4 bags that in each bag you have an X and a 5, right? So I'm going to attempt I've got a bag here that's got an X and a 5 in it. I've got a bag here. These are horrible bags. So that one, I don't know what happened to it, but X and 5. I got a bag here that has an X and a 5 in it. And I have a bag here that has an X and a 5 in it. So now if you're looking at this original problem up here, this guy right here, this original problem is saying, hey, I've got 4 bags, and these parentheses are your bags of X plus Y. So how many X's do I have? I have 1X, I have 2X, I have 3X, and I have 4X's, right? 4 X's. And then here I've got 5. Say that's $5 plus $5 plus $5 plus $5. I'm looking at 20 bucks, right? So 5 plus 5 plus 5 gives me that. So if I were to, this is just another way to model it, okay? Thinking of that parentheses as bags, okay? So if I had redone that problem for 4X plus 5, and I distributed and I did 4 times X, which is 4X. 4 standing next to the X means 4 times X, plus 4 times Y, which is 20, right? We cool with that? So this is what we're looking at for the distributive property. Now, the last one is, how does this help me in real life, okay? And what we're doing is, what helps in real life is, if you say you have 16 times 12, okay? You could look at this as, well, 10 plus 6 equals 16, right? Times 12. 12 times 10 plus 6, and 10 plus 6 is 16. You could distribute that 12 bit. Oh my gosh, everybody knows 12 times 10 is 120. I know that 12 times 6 is 72, right? Yeah, 12 times 6 is 72, Mr. Clark? Yeah, we got a thumbs up. And then this guy here plus this guy here, we can do in our head as 192. So instead of sitting there trying to struggle through 16 times 12, you can use the distributive property to help you with mental math. So this is the distributive property take 1. Okay, tomorrow morning I'm going to come together with the distributive property in take 2, and this is where the rain of hurt from the distributive property is going to rain down on us. But right now, check it out. Just remember that 12 has to get multiplied by the 10 and the 6, okay? And that's how I got this 120, and this is how I got that 72. And then I bring that addition sign down. And so, yeah, I don't mind it, you know? So we got that going for us, which is nice. All right, have a happy day. Hopefully I'll get these loaded up.